Hi guys, so this is my video for the coral reef food chain. Um, for my primary producer, I'm going to use seagrass. Seagrasses are the flowering plants which grow in marine environments. They say that there is about 60 species of fully marine seagrass. They are considered autotroph, which means they are able to form nutritional organic substances from simple organic substances, like for example carbon dioxide. They are considered benthic, which means they are the lowest level of a body of water, such as the ocean. And as well as seagrass can disproportionately benefit certain functional groups of nekton, such as pelagic schooling fishes and cryptic shoot, which means associated species. And they are able to swim and move independently through water currents. For my primary consumer, I am focusing on the queen conch. This refers to both the large marine mollusk and its shell alone. Queen conches are a soft-bodied animal belonging to the same group as clams, oysters, octopus, and squid. They live in shallow, warm waters on coral reefs or seagrass beds. The conch have pelagic larvae, which means that can move long distances throughout the water. That pelagic is the upper layers of the ocean sea. And the benthos means that they are bottom sediments. For my intermediate consumer, I did the Caribbean lobster, one of the largest on coral reefs and seagrass beds in the Caribbean Sea. And adjacent waters is one of the most valuable fishery resources for every country through its range. It is considered heterotroph, which means it is deriving its nutrient requirements from complex organic substances. And common for most of the benthic invertebrate, they begin life as pelagic, so they're water-dwelling babies, while they settle after a period, often weeks or months, and become benthic adults, which means they're on the lower level of a body of water, such as the ocean floor. And they are benthous also, so they're bottom sediments as well. My top predator is the blacktip reef shark, which is easily identified by the prominent black tips on its fins. Among the most abundant sharks inhabiting the tropical coral reef of the Indian and Pacific Oceans. This species prefers shallow inshore waters and is commonly found along the coastline of the Pacific regions. This organism itself is considered heterotroph. It is deriving its nutritional requirements from complex organic substances. It is also considered pelagic, what means it hangs out in the upper layers of the open sea. And as well as it is also considered nekton, which means it is able to swim and move independently through currents of water. So no matter how fast the wave is, it can get through on its own. The decomposer that I found on the website was the southern stingray. This is a whiptail stingray found in tropical and subtropical waters of the western Atlantic Ocean, from New Jersey to southern Brazil. It has a flat diamond-shaped disc with a mud brown, olive, and gray dorsal surface and white underbelly. So like most stingrays, their belly is white, as you can't see in this picture, and then the top of it is shaped like a disc and mud brown. This organism is considered heterotrophic along with most of the other ones, which means it is also deriving its nutritional requirements from complex organic substances as well. It is also considered benthic, which means it is the lowest level of a body of water, such as the ocean. So they also hang out at the bottom of the ocean. That's why if you've ever been in the ocean, you might have stepped on one, like a baby or whatever, as well as they tend to blend in with the sand. Nectotobenthos, sorry, I can't really pronounce that. Unlike the other ones, the organism that swims at the bottom of the lake or sea, like I just said. So you don't really see them on top of the water as much as you do on the bottom. And that's why they always say to be sure you shuffle your feet when you are in the ocean during their mating season, because their babies tend to hang out in the sand. Like I said, they tend to blend in with the ocean floor. So for my food chain, I used the same organisms that I got off the website. So my primary producer is seagrass. My primary consumer is the queen conch. Intermediate consumer is the Caribbean lobster. And the top predator is the blacktip reef shark. And finally, the decomposer is the southern stingray. These are different images that I used from the other slides, so you could take a look at those. A primary producer makes its own energy from the sun. So as you can see in this picture, the sun is reflecting off of the seagrass. Coral reefs need to live close to the surface of the water in order to collect that light from the sun, as it is their energy. So oftentimes they are very close to, like, the tips of them are very close to the top of the water, like kind of like seaweed in the lake, like you can see it coming up or whatever. These unique organisms create their own food by transferring the sun's energy into chemical energy using photosynthesis. So this is why seagrass is only found in the ocean or whatever, where it's primarily warm and they can depend on sun or whatever. And that's why seaweed is more like not as consistent, because it's in a lake, where in some lakes they experience a winter where they freeze and they're not receiving that light as easily. Using photosynthesis, they do transform the light into energy, and that's their food source. In this ecosystem, the primary producer are plankton and algae. For the primary consumer, the queen conch, the organism must consume or eat something else in order to get energy. So that would be the seagrass, anything that's plankton or whatever. This is what is consuming, as you can see, as well as this one's on the bottom of the sea as well. But eating something, the primary producer, is how they get their energy, and they cannot make their own energy to. They cannot make their own food to get energy. The primary consumer is always a plant eater. So, like I said, it's always seagrass or whatever. It's nothing. It's never an organism that they're eating or anything like that, such as an animal. It's more as plants. In the coral reef, you'll find many primary consumers. Examples of primary consumers are the blue striped snapper, angelfish, sea sponges, and shrimp. So not very, and if you can notice that they're not very big or whatever, because later they're going to be consumed by the intermediate consumer. And in my example, I used the Caribbean lobster. These organisms eat primary consumers. So this would be the queen conch, for instance. There are two types, carnivores and omnivores. Intermediate consumers are the sergeant major, flaming tongue snail, barjack, grouper, Caribbean lobster, bicolored damelfish, polychaete worm, cushion sea star, and southern stingray. So these ones are consuming the primary consumer, which consumed the primary producer. Moving on to the top predator, like I said, mine is the blacktip reef shark. The top predator of a food chain is the carnivore within the community that does not have any predators of its own. So it is not really fearful of anything, as it knows that it is pretty well sized and it has a easy way to protect itself against anything else, unlike the other like primary consumers and everything. When the top predator dies, their remains are broken down by decomposers, which I will get into next, which are bacteria and fungi. This is an animal that hunts and eats other animals. So we always see that sharks are always lurking in the ocean or whatever, and that's their job. That's how they get their nutrients that they need. And the prey is the animal that gets eaten by the predator. So that would be the Caribbean lobster that ate the queen conch, that ate the seagrass, that received energy from the light. Lastly is the decomposer. The southern stingray, for instance, is what I used. Energy is transferred through the consumption of organisms. They break down dead animals, so this would be the top predator, and plants in return vital nutrients. So they turn that into nutrients for themselves, and these nutrients are used by the producers during photosynthesis to create energy. So that would go back to the primary producer, where we're getting that sun from the energy is being received from the sun. And this completes the cycle. Examples of decomposers are fanworms, sea cucumbers, snails, crabs, Bristol worms, and bacteria are decomposers in the Great Barrier Reef, which is talked about in the chapter that we were assigned this week. The abiotic factors, these are non-living chemical and physical parts of the environment that affect living organisms and the functioning of ecosystems. Some of the abiotic factors that are specific to coral reefs are oxygen, water, CO2, sand, rocks, shells, temperature, light, hard substances, and waves. Oxygen is needed in the process of the biome because it is one of the main essentials for life, as well as physical processes that link living, which are biotic components like plants, animals, and decomposers, to the non-living abiotic components, which is temperature, light, and moisture, in hot, semi, and grasslands and other biomes. Temperature and sunlight are two abiotic factors known in nearly every ecosystem. But since the Great Barrier is an aquatic ecosystem, it has additional abiotic components. These include buoyancy, viscosity, light penetration, salts, gases, and water density. So like we talked about in the food chain, sunlight plays a huge role in it, as well as it starts with sun, like we talked about right here, as the primary producer, because the sun is what is starting the cycle, as it is feeding the seagrass what it needs to become energy. So then moving on, the primary consumer will consume the seagrass. Buoyancy refers to the force that supports the weight of an organism. Viscosity is the resistance to the movement of the seawater, and these two abiotic factors contribute to the movement of fish and sea animals, as well as the light penetrates the ocean surface only about 20 meters. So that's why it's important for that seagrass to be close to the surface of the water, because the sun can only travel so far. There is much more salt in the Great Barrier Reef than in a freshwater ecosystem, and some biotic components that live near estuaries where fresh water mixes with salt water have to deal with changing amounts of salt in the water. It's never consistent. So it's something that they have to watch and maintain for people who study the ocean and people who that's their job, because it's important to make sure our aquatic life is getting the right amount of salinity and not too much where it is affecting their health. Water contains less oxygen than the air. Also, the density of water in the Great Barrier Reef changes with depth. This changes the biotic components that can live in a given depth. So it has to be animals that can deal with that changing of depth or whatever. Impacts on the coral reef. There's a lot of threats to the coral reefs that are physical, chemical, geological. These are ones that I was able to really focus on. A huge one was increased ocean temperatures and changing ocean chemistry are the two greatest global threats to coral reef ecosystems. These threats are caused by warmer atmospheric temperatures and increasing levels of carbon dioxide in seawater. The physical ones that I was able to pull out were destructive fishing practices, pollution, and invasive species threatening local coral reefs and populated areas. Climate change and ocean acidification also threat the coral reef around the world. Without careful management of human activities and an active reversal of global threats, entire coral reef may be lost due to these factors. So it's important that we're doing responsible practices when it comes to our ocean, and we know what we're getting into, and we know what we're putting into the ocean is only good for the organisms. The chemical aspect, an estimated 20% of the global corals are threatened by exposure to toxic substances. The main chemical threats are pollution by oil and dispersions, industrial chemicals from discharge, and pesticides from runoffs, anti-folding compounds, and chemical fishing practices. So again, that fishing practices, this is where human interaction comes in, and that we need to make sure that we are doing those appropriately. And the geological impact on the coral reef. Coral reefs protect coastlines from storms and erosion. They provide jobs for local communities and offer opportunities for recreation. They are also a source of food and new medicines, and over 500 million people depend on reefs for food, income, and protection. Some threats are natural, such as disease, predators, and storms. Other threats are caused by people, including pollution, sediment, the fishing that I just talked about, the climate change, which is raising ocean temperatures and causing ocean acidification. Many of these threats can stress our corals and lead to coral bleaching and possible death, while others can cause physical damage to these delicate ecosystems. Rising water temperatures and ocean acidification linked to rising carbon dioxide levels. In result, high water temperatures cause corals